Okay, so for light incident on a diffraction grating, the transmitted or reflected light will be such that the equation d sine theta equals m lambda is satisfied. So what does that mean? If we have a grating and a beam of light incident on it, if it's a transmission grating, then you will have some that is transmitted undiffracted. That's with m equals 0. But if m equals 1, then we will have a diffracted beam transmitted at an angle from the normal that satisfies this condition. So if you have polychromatic light incident on the grating, like this red and blue light, then what will happen is m equals 0 will contain both, and the red will be diffracted at a different angle than the blue beam. So spectroscopy is a pretty fundamentally important tool because of the relationship between energy and wavelength. Spectroscopes can be used to measure wavelength and therefore energy of light. So it finds applications in physics, astronomy, chemistry, biology, all sorts of other fields besides just physics. So let's take a look at one of our instruments here. So this is one of our lab spectroscopes. I'll give you sort of a quick tour. Over here, there's an entrance slit. There are basically two facing razor edges here, and one of them can be adjusted with the screw to open or close the slit. And then this arm has optics that basically take the image of the entrance slit and project it back to infinity so that the light rays are traveling essentially close to a plane wave when they're incident on the grating. The grating is inside here on this little turntable. You can see it's got a little black frame around it, but there's a grating mounted inside of there. So when light from the slit is incident on the grating, some of it will be transmitted and some of it will be diffracted out to various angles. This side is the telescope arm and basically has an eyepiece in it and another lens that lets you look at the grating as if you were far away, essentially. So there's also a reticle in here with crosshairs on it that lets you precisely center the eyepiece on any given feature in the spectra. And the telescope arm here rotates around. So you can imagine the beam in here diffracted out to different angles depending on the wavelength. And by rotating it, you can center the arm on any given wavelength. And then at the base down here, there's a vernier scale protractor that lets you measure the angle that the spectroscope has been rotated out to.